Yeah. No. That's it. Hello, hello. I'll put it again. Why didn't do that? I should have went. No, that's right. See, it's not equal to 100. I'm gonna do this. Something wrong. How y'all doing? Let's see how many people done signed in. Where is it here? 3. We'll wait on others. Oh. Okay. No, what happened? Oh, no. Okay, so while this CH is not equal to this. Right. Phone. Okay. Okay.
Am I muted?
What happened? Okay.
Can you hear me? Am I muted?
I can hear you.
Okay, I'm sorry. This coronavirus stuff is crazy, huh?
Yeah, I tell you, I don't understand what's going on. Don't know what's happening. Summer 3 and 2. Okay. Execute while it's not equal to then while CH. Oh. So either one of them. Oh. It can't be both. Can I stop it? That's right. And the wrong thing. All right, let's see how many people in the class. There we go. So many people in join. We have 5 people. Okay, wait about 1 more minute. Last class period, we stopped on the while loop. So let's start this. I wrote this little program a little while ago. All right, so let's get started. Okay, we're gonna go over the do, but let's kind of refresh the while loop. If you look at this program have one while loop that controls all of this, and then we have a while loop within a while loop. The outer while loop allows us to perform this in one number, in a second number. It adds the 2 numbers and then it gives the sum. Then it prompts the user to whether or not they want to execute that procedure again. Now, on last class period, we didn't put any validations in. But if you look down here, what I did was I put a while in. Once we put in a choice, we controlling whether or not they can input a valid, well, whether or not they can just give garbage or whatnot. Because if you look here, it says CH, right? Then it says while CH is not equal to Y and CH is not equal to N. So what happens is if I put any other character than Y or N, it falls in here, right? And so it's going to stay in here and stay in here and stay in here until I enter a Y or N. When I input a Y, then what happened, it make one side true and the other side false. Otherwise, if I put say the letter E, both sides will be false. And it'll stay there because that's a not equal. So let's run it. All right. And notice I got my curly braces to section off my block for my while, inner while, and then my curly braces open and close to section off this entire while. So if I run this program, when I run it, okay, enter a number, enter 3, enter a number, enter 8. Oh, what? I thought I put 8. It running slow. All right, say 8. All right, that gives me 11. But then execute again. So at this point, we are at this point. We're right here. All right. And so now if I put in any character, Q, now I'm stuck in that inner loop. It's just going to keep asking me. And I could have put another prompt. I could have said, please type in a Y or N to continue. So anything I put, it's just going to keep on continuing within this while loop here. So that means I'm controlling the user from just typing in any character and then all of a sudden they're saying, oh, why is the computer doing this? I didn't tell it to do this. So if I type Y, now it'll go, oh, well, what happened? I did Y. Oh, so I typed Y, and now it's asking me to do what? Enter a number. So what happened is start it over again. So I can type in 88 and 22. It gives me that. And then if I put no, it kicks out the program. Okay, so that's the while loop. Anybody have any questions about the while? With the while, there's, and even with the for loop, even the do, there's three components. Number one, you have the actual variable and the value or value that you actually starting with. So in this case, we're saying what? Char or ch equal y. Then we have our test condition. So we set char ch to y, and then we say while ch is equal to y. And then we want to do this, all right? And then we perform this. And like I say, we could do this. And then if we say while it's equal to y, we have to what? Somewhere in here, what? Prompt the user to input a value. Otherwise, they're going to what? It's going to stay equal in the y, and it'll be what? A continuous loop, an infinite loop. Okay? So that's the while loop. And you what? It said that it was a pretest loop. Because what? It has to test to see if this is true before it actually performs these statements. Okay? Anybody got any questions about the while loop? About the while loop. All right. So, all right. So now let's look at the do while. All right. The do while performs the same action, such as repeat a body of a block of statements, but it guarantees that you execute those statements at least one time. That's the way the do while works. All right. Now, so it says both the while and the do while iterates as long as a condition is true. All right. Sometimes, however, it's more convenient to write a loop that iterates until the condition is true. All right, that is a loop that iterates as long as the condition is false and then stops when the condition becomes true. Okay, but that would be like the do until, but well, not do until. Well, wait a minute, class. We're gonna skip this do until because the do until is like the not portion of do while. All right, so read up on this information, but we're not gonna write code dealing with the do until, because the do until is kind of like the reverse of do while. All right, until you're trying to reach a negative, saying if as long as it's not this, do this, which is like a while, a do while. So read up on this, but when you get in the upper level classes, you won't see an until. All right, in C++, you won't see that. So let's skip over this and let's get to the do while. All right. Well, let's see. But it talks about it. So where's the do while? But it is the do while though. They got do until, but we're gonna call it's the do while. All right. You won't find this. If you try to search this online, you won't find do until. It's do while. All right. So how does the do while work? Is that statements are executed and then the condition is checked. And I'll show you what happens. Like say we got this while here. So what I can do is I could revert this and take this off. Well, what I'll do, I'll put a do here. All right. This says do. All right. But then I would have to take this off of here, remove this, and at the end of this, and then I'll have to put a semicolon. Now, I know this is a big, wow, I could have created a smaller program, but I'm using the same one. So what this says to do all of this, okay? It's going to do it what? At least one time, because the do, there's no condition. It says do it, okay? So it's going to perform each one of these statements. Then it's going to get here if you want to execute again. If you put Y, then it's going to drop down here because what? This is going to be true, that's false, so it won't perform this. So you get here and it says it's equal to Y, so it goes all the way back to the beginning of the do and continues again. So everybody saw how I modified this program to where it did the do. So if I do it that way, I do not have to initialize this at the beginning. And what I'm going to do, I'm going to comment this out. Because what? All I need to do is do char ch. Because at this point, I'm not testing. It's just going to fall through the logic. And then right here is where I'm going to input. And then I'll test here. And then I'll test here to continue the entire loop. Okay? So everybody see that format. So let me run it right quick. And it should run basically the same way, except it won't test. It will automatically give me this. I'll put in 2 and 3. We'll get that. I'll put in an F. See? Execute again. Put in a G. Execute again. I'll put in a Y and a number. Okay? 44, 22. So the program is executing the exact same way, but with this one, it will not test to see whether it needs to execute those statements. It will automatically execute those statements. Now you might say, well, why would you use, or what's some benefits of using a while statement? Say for instance, you had a module, and that module had a menu. You wouldn't have to write a program and initialize a value or give a value to a variable just to make it go into the loop. You could do a do and then do the while. So the do will just say what? Display the menu, and then you have while whatever. So it'll be performing. It would display and then perform the loop. Okay, so that's some of the benefits of doing that. You can have the information displayed at least one time and then have it checked repeatedly depending on what value is being put in or whatever. Okay, so that's the do while. So let's look at what it say, because we're gonna read it. We're gonna read it somewhat like do until, but there's no do until. There's do while. All right. So it says a loop that iterates until conditions is true is known as a do until. All right. And it's shown here, and it's like a do while. So remember, we had do, and then we perform all those statements. And at the very end, we had the condition with a semicolon at the end. And if it was true, well, really, they did the reverse. But if it was false, but still, we're going to do it like a do while. And they're going to be performing until it's false, or like I say, false or true. You can make it to where it's false, and then it kicks out. All right. So that's the do while. Just kind of confusing. Let me see the do. Let me see if we got a do while in here. No, see, they go to the for statement. And I don't want you to be confused. Yeah, see? See that? Why would they do that though? Yeah, it's a do while. It's a do while. We're gonna use the word until, but it's a while. All right, it's a do while. Let me get back to the chapter section. All right, so here we go. Now, and look, here is the example of the pseudocode. Do, just like we had in the program, whatever statements you have, and we don't use the command until, we use the command while, and then whatever the condition is, semicolon, all right? And all these statements here are going to be in what? Curly braces, all right? So they will be in curly braces. So that's the general format. So if you look here, same thing like we did, do, and then you prompt the user to enter a password. And then if the password is not equal whatever, then sorry. Until password is equal to this, we coming back and do this. So we doing this, all of this routine. Each time a person enter that, for this run, if they enter the wrong password, it's gonna keep on prompting them to enter a password until what? The password is equal, and then it'll kick out, okay? So, and this is what it's showing. When the program is run, enter a password, they enter Arial. Arial is not, sorry. Enter password, they enter Caliber. It's wrong. It's wrong, and so sorry, enter password. Then they enter the Prospero, and then what happens? Then it was confirmed. All right. So that question. Hello. Yes. Somebody had a question?
I didn't.
Huh?
I didn't.
Oh, okay. All right. So see what happens? The variables is declared. All right. Because what? You got to declare password. Even though you don't give it a value, it has to be declared. Then you do the do, and then what? Password is going to be inputted. Once it's inputted, it's tested. If it tests to see if it's correct. If it's correct password, then it exits. But if it's not, it's gonna go back, and check to see, if it's this one. It's gonna come back. It's gonna keep coming back, keep coming back, keep coming. Oh, what happened? This is my fault. I don't know what happened. And it's gonna keep coming back until that password is valid. Okay. All right. Well, one more, chapter 6. All right. So now, let's see. So I'm trying to get to the for. So that's the we did the while yesterday. We did the do. I did the for. We did the do while, and then we'll do the for statement. But they got some things in between. All right. Now it says deciding which loop to use, whether you're going to use the do while or the for. Oh, here we go. Talking about do while. Deciding which loop to use. In this section, we have introduced 3 different types. I didn't see the do while though. Of condition controlled loops. All right. The while loop, the do while loop, and the do until. Like I said, we did the while, and like I said, we discussed the do while. The do until just is like the reverse of the do while. Like you do a negative, you performing the procedure if it's not whatever, but it's just like writing a while loop. Kind of like me asking if x is equal to greater than 3. I could say if x is not greater than 3. So it's like you can always write the code to do the not version of it. All right. So when you write a program that requires a conditional control, that means what? You got to make sure the value is a certain value in order to perform that loop. You will have to decide which loop to use. All right. So you want to use the while loop to repeat a task as long as the condition is true. All right. And like I say, that's the while. The while loop is ideal in situations where the condition might be false to start with, and in such cases you do not want the loop to iterate at all. So remember, like the program we just had, we can have that program, and we could have said, well, if value or if name is equal to whatever, set choice to no, and then what? You don't want to perform that loop, so set it to end, and end will allow it to exit out, or not even perform it, just continue on. But if it was set to Y, that pre-test, and then it'll fall into that loop. Okay. It says the do while loop is also a candidate in situation where a task must be repeated as long as the condition is true. It is the best choice, however, when you always want the task to be performed at least once. So the while loop, you have to have the test condition true to fall in, but then the do while, it actually performs it one time, and then it will actually check and then perform over and over until the condition is false. And it tells us about the do until. The do until and the do while is similar, but you won't find situations with C++ where you got to do until. The loop also performs a task at least once, right? All right. And it is the best choice, however, when you want to perform a task until something is true. So like I say, it's like you can take the while loop and just reverse the logic to do whatever you need to do. So a do while is pretty much suffice for that. So when you get to 193, you won't even see do until. It'll be the do while. Okay, but now other languages might have something with a do until. Okay, but let's look at this. We have a for loop, our for statement, and with the for loop, and this is a count control loop. And what that means is I could write a loop and specify based on what I put in it, what I specify in the header for that loop, how many times I want it to perform, right? Given the starting point, given the test, and given the increment or decrement. I can control how many times I want that loop to perform. If I want it to perform 5 times, I can do that. I can't do that with a while loop. A while loop going to test a condition if a value is true or whatever, you know. But I can control it. I can make it somewhat like a for loop, but a for loop, you can do it only in that one statement. So let's look at this. It says a count control loop iterates a specific number of times, although you can write the logic for the condition control loop, which we talked about. So it iterates a specific number of times also. Most language provides a loop known as the for loop, okay, which is specifically designed as a count control loop. But you can make a while loop do the same thing, all right? And we'll do that. I'm gonna do all 3 of them, because remember, you're gonna have assignments to do with all 3. And what I'm gonna do, we're gonna do examples of all 3, like say in one program, all right? So what it is, basically with this loop, you're gonna have an initialization, and I'll show you what that is. You're gonna have a test, which you're testing your value if it's either greater than, less than, not equal to, whatever. And then you're gonna have an increment or a decrement, however you write in the code, okay? So those are the 3 parts of that for loop, okay? So what happens is you're gonna have an initialization of a value. Then you're gonna have it test a condition. So you set it equal to whatever, that's the initialization. Then you're gonna have it tested. When you have it tested, if it holds true that it either not greater, not whatever, then you perform the true condition, and then what? It's gonna increment by 1. But all that's done in one statement. Even though you see multiple sections of this flow chart, it is done in one statement, and we're gonna look at that, okay? So now, it says in the flow chart, assume that counter is an integer variable, all right? The first step is to set the counter, and that's what we're gonna do that. Notice what they did here. They set it to 1, all right? Now, the second step is to test it, all right? They got counter less than or equal to 5. So let me ask you this question. How many times will it loop here? It's starting at 1, and it's stopping at less than or equal to 5. So it's going to perform this how many times? How many times will it print out hello world? Anybody? All right, what I'll do is I'll write the code. Let's write the code right quick. Nobody give an answer yet. Let's write the code. All right, so we do the return 0. So what it said, all I need to do is what? For, this is the format. Int, and to give a variable, I'll say count equals, and they say what? 1, right? Semicolon, that's just the format. Count less than or equal to 5, semicolon, count plus plus, that's the increment, okay? Now, remember what we said, by default, with an if statement, with a while statement, even with a for statement, you do not have to have curly braces if you have only one statement. But like I said, sometimes you run the risk of forgetting that when you modifying your program and have to add more statements, and you forget that, oh, I gotta have this block. So I would say always block the data, and that way when you add, and you know you have to add it here. So if I do a cout here, how many times hello world will be printed? 5 times. It's gonna print the 1, it's gonna say, okay, 1. All right, count is equal to 1. It's gonna say count 1 is 1 less than 5, less than or equal to 5? Yes, it is. Okay, it's gonna print. Then it come back, it's gonna increment by 1. 1 becomes 2. Is 2 less than or equal to 5? Yes, it's gonna print. Then it come back and increment by 1. 3, is 3 less than or equal to 5? Yes, it is. It's gonna come back, it's gonna increment by 1. It's gonna be 4. Is 4 less than or equal to 5? Yes, it is. It prints. Then it come back. It's 5. Is 5 less than or equal to 5? Yes, it is. It prints, and then it come back. Increment by 1 is 6. Is 6 less than or equal to 5? No, it stops. So it's gonna print 5 times. So I could take these spaces out. Spaces don't cause errors or nothing, but I'll just make it where you can somewhat see it. So if I do this and I run it, we should get hello world 5 times. See? 1, 2, 3, 4, 5. Now, what I can do is I can say, okay, well, let me see if I can print out X. So what I can do is this. I can do this. Then I'll just do X. And now when not X, it's count. Because see, count is being incremented, right? Count is my variable. See, I could have used X, but there would have to be X, 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 and X. So let's run it. When I run it now, 1, 2, 3, 4, 5, and when it gets to 6, it kicks out. Okay? So everybody see how that for loop works. Questions? Question about the for loop. Now, remember we said we could make a while loop do the same thing. With the while loop, I could do what? I'd have to modify this. And what I'm gonna do, I'm gonna copy stuff and show you it's pretty much the exact same commands, but with the for loop, you do it a different way. So I cut this and I'm gonna paste this here. All right, that's my what? Initialization. All right, so now rather than for, I'll say what? I'll say while. Okay, then rather than me doing count plus plus here, I take this out, cut this, and I add it inside the body of statements, but I need to add a semicolon because this is the end, and I need to take this semicolon off. I've just created a while loop that will perform how many times? 5 times. So if I run this, I've just done the exact same thing. All right? So what I did, I took that for loop and just modified it to run like a while. Okay? Now, we can do the same thing with the do. All right. We got it initialized. Okay. We would take this, all right, take this off, cut this, paste this at the end of my body, add a semicolon at the end, if I could type one, and then put my command what? Do. All right? So everybody saw what I did. Rather than put a while here, I put do here, took the exact while statement and put down here, and now when I run it, I should get the exact same thing. See? 1, 2, 3, 4, 5. So see, we looked at the for loop, took the same for loop, or took the same statements that made up our for loop, created a while loop, then took those same statements and did a do while loop. Okay, so all of the loops they pretty much work similar, but they have different purpose. All right, they have different purposes. All right, questions. So let's look at the for loop again, though. All right, so the for statement. So look here, you got for, and what we had the actual counter variable. Okay, remember whatever we had, count equals to 1. All right, and then we had our test condition, count less than whatever, and then we had count plus plus, and then this is our body. Open curly brace, close curly brace, and that was it. Okay, that was it for that. And this just explains to you what happens. The counter variable is set to a starting point. The counter variable is compared to the max, and then if it hasn't reached it, it's gonna keep looping. But when it loops to come back around, it's gonna increment. Now, I'm gonna ask a question. Let me just go Control Z. I'll go back if I can click here. All right. So we know that many people have many different ways of thinking. All right. So I could ask somebody to say, okay, write a program that will perform this 5 times, and they will give me this, right? Okay. Then it could be somebody else who write the same program, and we went from what? 1 to 5. Somebody else might write it, and they might go from 95 to 99. Well, yeah, 96 will go from 96 to 100, 95 to 99. But somebody else can write it, and they can go from 0 to greater than a -5. You understand? So either way it go, you're doing the same thing. You're allowing the program or the loop to perform X number of times. Give you an example. I could start counter at 0. All right. I'll start it at 0. All right. But then I'll change this. I'll say count greater than -5, all right? Then if I'm doing that, how can I go from 0 to -5? How can I take 0 and go to -5 in increments of 1? I would have to subtract 1. So rather than do a plus plus here, I would do a minus minus. So what happened when X is 0, is 0 greater than or greater than -5? Yes, correct. If then it increment. I'm going to decrement. 0 become -1. Is -1 greater than -5? Yes, print and decrement. Is -2 greater than -5? Yes, print decrement. -3 is -3 greater than -5? Yes, print decrement. -4 is -4 greater than -5? Yes, it is. Print then decrement. -5 is -5 greater than -5? No, it kicks out. So it doesn't matter which way you go, whether you go from positive to negative or negative to positive. as long as you want to iterate X number of times. So let's run this and see how many times. And I took the double, it ain't gonna double space now, it's gonna single space. So that's the only difference gonna happen, but watch. See here? It started at 0, 1, 2, 3, 4, right? So 5 times, right? I could also do what? I could go from 95 to less than 100. And then I have to change that to plus plus. That's a count equal count plus or 1. So when I run this, it's going to do 95, 96, 97, 98, 99. It's going to kick out at 100. Let me take this back up. So when I run it, all right, so everybody see that. It still did it what? 5 times. So you as a programmer, if you wanted to perform, if you're doing something you perform, and this number is not necessarily is used as some kind of calculation, but you just using it to do something X number of times, you can do it any kind of way you want because the system will take it, okay, test it, and increment or decrement and allow it to perform that many times. Now, I got this question, all right? So I'm gonna go back to the conventional way. Say we wanna perform this 10 times, all right? We start at 0, this would be what? If I start at 0, I have to do what? Less than 10, right? Not less than or equal to. Less than or equal to 10 would give me what? 11, okay? But what I can do here is, now, if I do something like this, count, what have I just done? Well, first of all, I'll tell you what, I'm gonna comment it out and let's see it print 10 times. So let's see. Okay, so it prints from 0 to 9, which is what? 10, right? So if I add this statement here, what will happen? How many times will it print hello world? Anybody?
10.
Okay, let me ask you this. If I'm doubling up on the count, how many times will it print hello world? If you had a bank account and they give you 10 transactions in a month, but every time you go, they're charging you two transactions at a time. How many transactions you gonna have for that month?
5, if you go.
5. Same thing here. Look what happens. Count is 0, right? So it goes through. It's gonna print. It's gonna increment, correct? Then it's gonna increment again. So rather than be 0, it's gonna be what? I mean, rather than 1, it's gonna be what? 2. And then 2 is less, it prints, it gets 3, then it gets to what? 4. So you understand what's happening? Being that I have it here and I have it here, I'm doubling up on my count. Everybody see that? So when I run it, see? I only got 5, what? At 0, 2, 4, 6, and 8. So everybody saw what happened. So when you writing code, and if you wanted to put a control loop in there, you got to make sure that you're not doubling up on your count or changing your count to a value or whatnot, which causes your program not to iterate the right number of times. But everybody see what I'm showing, right? How it can change if you add something in there. All right. So now, I don't know if we talked about infinite loops, but if I do this, what'll happen now? I just changed count to count plus plus to count minus minus. What will that do? That will negate the plus. So count will always be what? 0. Because what? First time through count is 0. I'm taking away 1, it's -1. Add 1 back, it becomes 0. Print. Taking away 1, -1. Add 1 when I get back to the top, becomes 0. So see what happens? Now I'm caught up in a what? An infinite loop. So let's run it and see. See what happens? And we can't really see it scrolling up on the screen, but it's always printing 0 and hello world, 0, hello world, and it's still scrolling. We just can't see it scrolling because 0 is not changing. I mean, the account value is not changing. But everybody understand that. I'm negating this addition when I subtract down here. So count will always be what? 0. 0 is always less than 10. And now I'm stuck in a what? An infinite loop. Okay? Everybody see that? All right. So now I stopped it. I'm out of it. Now, normally what I would do, and like I say, I got it up to 10. I done gave this assignment once before to one of my, but this is my upper level classes. An example, write a program that will print out, and I'll give me a number from 1 to 10, anybody. Give me a number from 10. All right. So he said 10. So what I'll do, I'll do this. I'll do something like this. I can do it here. Const, right. 10. So what we're gonna do, we're gonna take this loop, all right, and using this value in this loop count, we're gonna take the 10th time and create the 10th time table from 0 to 10. All right. So what I'll do in here, all right, I'll create another variable. I don't have to because I can see out it. I'll say value. All right. So now I could do the first time through. I could say what? Val is equal to count times times. Right? Then I want to see out a val, and then I want to see out. And like I say, I put my double quote, and I'm gonna print out this and say val, not val, count times, and I'm just time whatever, and times, all right, equals, and this will be val, all right? All right, I don't want to do it inline, I'll do it like that. So each time through, when count is 0, it multiplies count the 0 times what? 10, which is time. The second time through count is what? 1, right? And then it's gonna multiply it and get whatever. So let's run this and see what we get, all right? And like I say, simple timetable. So see what happened? We've just wrote, using this for loop with what? Maybe what? 8 to 10 command, 8 to 10 statements to print out what? The timetables, right? Of 10. So what? 0 times 10 is 0. 1 times 10 is 10. On and on. And if I wanted to change this to another times table, let's say 6, all right? We change our constant value for times to 6. So now when we run it, here we go. It's our timetables for 6, all right? And see, I could have done less than or equal to 10 to make it normally equal, but all right, so now it'll do all the way up from 0 all the way to 10. All right, so see how you can manipulate the the for loops to do certain things that you want to do. You can multiply, do whatever, but you can also have all that if logic, while logic, and anything else in a for loop, just like you can do in a while loop. Okay? Questions about those loops? Questions? Questions? All right. So let's take, all right, so say we have this loop. Let's take this loop. I'm going to copy it. And like I said, I'm going to just copy it so I won't have to redo it. All right. We're going to copy this loop. I ain't going to do int value. Take just the for. All right. But in your assignments, you got to do a for, a while, and a do while. So let's convert this to a while loop. Right. So this is the for loop up here. All right. We'll change this one. I'll do something like this. All right, so that'll be that one. So let's make this one a while loop. To make it a while loop, we'll change for to what? While. And now this gonna be a key, and like I said, you might, being that it's all in one, your program was gonna be separate programs. Let's change count to CNT. So if we change that to CNT, we're going to have to do int CNT, all right? All right? So now we're going to say what? While CNT, all right, equals 0, all right? Not equals 0. Is less than or equal to 10. Okay? And I'm going to take this off. I'm going to type it this time. All right. Then this is our body, right? But what do we need to do inside the loop when we have a while loop in order to not have an infinite loop? We have to do what? Increment CNT. So CNT plus plus, all right? We have to do, we could do it like this. CNT is equal to CNT plus 1. Same exact statement, all right? Now, that's going to execute, and I should get the exact same result twice, all right? Oh, no, my fault. This got to change to CNT because CNT is what's being used in this program to for this loop, all right? We changed it. So when we run it, now you should get 2 of the identical outputs, all right? Well, where is it? Wait. No, it just stops. Let me see what happened. See how this. Oh, it didn't fall in here because I didn't declare it, right? Remember we said the while loop is a test, a pre-test? So CNT was not given a value, so it couldn't compare it. In Visual Studio, I would have gotten an error because once I try to compare this variable, which has no value, to the value 10, it would have given me an error, all right? So when I run it, now I should get the exact same thing. So here we go. See here? This is the first one. This is the for loop. And this what? This is the while loop. Exact same thing, but what? One is a for loop, one is a while loop. Okay? Questions? Questions? Okay. Let's look at the do while. All right. So what happens is I'll copy this while loop. I want to copy all of this. And I'll change the variable on this too. Copy this. So I'll copy this while loop, and now I'm gonna make it a do. So if I'm gonna make it a do, I know I need to take this because this is my test. If I try to retype it, I might make a mistake. So I'm gonna cut this, and I'm gonna just paste it at the end of this and put my semicolon. And then all I have to do is what? Do. If I'm not so, do. Okay? And now I have my do while. All right? Do this while CNT is less than 10. But now if I wanted to change CNT to something, I'll say, okay, I'll change this to say X. Right? So now X is equal to 0. But now when I do it, X is 0, so I need to multiply count by times by X. And then I need to output, where is that? Not CNT, but X. Hopefully everybody's seeing what's happening, all right? And then here I need to what? Increment CNT, all right? CNT is equal to which X is equal to X plus 1. So that eventually here I can what? Get to either greater than, something greater than 10, all right? So now, if I run it this time, I'll just put the word for in here. While. And I'll put in here. All right, and that's the do while. So let's run it now. I think I got all the errors out. All right, so when we look at it, we have, this is our for loop, this is our while loop, and this is our do while. All three performing, giving you the exact same output, but have a little different way of writing it in the code. All right? Everybody got that? All right. Now, let's go back to the notes. All right? So, and this is just with the for loop. All it's doing is we have our max, we setting our we got a constant max value. You can do that, and now they're using max value as the value. So that'll be for int, whatever. It could be x equals or counter equal 1, counter less than max value, less than or equal to max value. But max value what is what 5, but they made it a constant. Yep, perfectly all right. It's a variable with an assigned value. And as long as it's less than 5, you're doing this, you increment. Doing it, you increment. All right, you're not going back above this because you don't want to set it back to 1 each time. And that's the loop. All right. So, and look, this is an example of a program that squares a number. What we did, we multiplied to get the what? The times table. What they did, they just did what? CNT times CNT. Because what? The first time when CNT is 0, 0 times 0 give you the square. When CNT is 1, 1 times 1 give you the square. When CNT is 2, 2 times 2 give you the square. So that's all they did. Or you can use the what? The square, the power function by loading the math library. Okay, either way. But when you multiply two numbers, you get the square. All right? All right. So basically that's what they're showing here. They did all this at the beginning, the initialization of the variables, the output heading, and then the output dash. I used the asterisk a little while ago, remember? And then you got your for loop. All right, this would be for counter equal 1, counter less than or equal to max value, when max value is equal to 10, all right? And then you actually squaring the number, all right, displaying the square, then you incrementing by 1, all right? Is 2 less than max value? Yes. Squaring 2, printing out 2 and 4, and then increment by 1 until what? It gets greater than 10, and then it ends the program. So that's basically what it is. This is the pseudocode, all right? The pseudocode that does that. Okay, this is your heading that is printed of the page, and this is what? For counter equal 1. Then it would be counter less than or equal to max value, and then you would have counter plus plus. And then this would be your statements inside open curly brace, close curly brace. And now this is your result. All right. Anybody have any questions? All right. Now the increment. All right. Let me show you something with that. Because some people probably seen it and they probably say, well, Mr. Lester, I don't really know what that is. How does that work or whatever? It's kind of tricky, but you're really going to learn about it next semester, right, in the next class. If I have a value here, if I say int x, let's say x equals 3, y equals 4, z equals 2. Now, like I said, whatever. All right, so now, if I do something like this, and I'll do total. If I do something like total is equal to x plus minus y, well, minus plus y. Well, I'll just leave it at that, short like that. Looking at that, you might say, well, Mr. Lester, that's look a little bit confusing, right? This is the deal. Remember with the for loop, we talked about this plus, and then we had minus. This plus can be a pre, which means can precede a variable, or it can be a post. It can be post or following the variable. It plays a important role as to what is to be done, depending on whether it's pre or whether it's post. Looking at this, who could tell me what the value of total is? Just using your math skills, what do you think the total is? Anybody?
One, right?
Okay. All right, let's look at it. All right, because I just wrote it. So
does plus not actually mean plus?
Okay, so x is equal to what?
3.
3. And it got plus, but it's post, okay? Y is equal to what?
4.
4, but it has plus, so that means it changes to what? 5. Now, this is the rule. If this operator, this plus, or minus is pre, you have to increment before you add or subtract or divide or whatever. You have to. If it's post, you're going to change the value of that variable after you leave that expression or after you leave that line. So looking at this, x will be, on this line, x will be 3. But when we move to the cout statement, x will become what? 4, okay? On this line, x is 3. When we leave this line, x is 4 because it's post. You don't do anything to the variable if it's post. But looking at this one, y is pre. So on this line, y is 4, but we have to increment, which makes it what? Makes it 5. So this statement is really saying 3 minus 5, which is going to give you a what? A -3. I mean, a -2, right? Hello? All right. So when we run it, it should give us, if I can pull it up, a -2. See here? The answer is -2. Now, what I'm going to do is I'm going to print total. Now I'm going to print x. And what you're going to see is the value of x will change to what? 4. All right? And the value of y will change to 5. But X will not change to 4 until we do what? We leave that line. See, that's the difference. So I'm going to run it. See here? So X did turn into 4, but it only turned to 4 when what? Once we left this expression and went to the next line because it's post. Y turned into 5 on that line because it was pre, okay? So 3 minus 5 will give us a minus 2, okay? Now, I think I could do it this way too. What I'll do, I'll comment this out, and I'm gonna show you. If I comment this out, and I'll print out X plus plus, that should give me what? If I output X plus plus, that should give me what? 3, right? And if I output plus plus Y, that should give me 5, correct? So if I run this, I should get 3 and 5. See here? Look, X plus plus, but if I print out X and Y again, I'm gonna copy this, and I'm gonna change the output, all right, but what I'm gonna do, I'm gonna take the plus plus off. All right, I'm gonna take the plus plus off, and I'm gonna just print out X, and I'm gonna just print out Y. So run it again. So see what happens? Now, X plus plus, on that line, X is 3. Once we left that line, I didn't do anything else. This is the only place I had the expression. X now is what? 4. Plus plus Y turns into 5 on that line. But what? And then when it moves to the next line, it still is 5. Everybody see what's happening? Questions about that, pre and post? Questions? Everybody understand that though? Because like I said, we're not gonna work with it as much now in this class, but it's good for you to know and kind of somewhat understand, because when you write that for loop, you need to know that X plus plus, or when you write that while loop, you could do count plus plus, you know that's count equal count plus 1, all right? So like I say, but it only increments if it's in pre, after you leave that line, and if for the next line on. And if it's, pre is for all on that time and that time continuous. If it's post, on that line is the original value. As soon as you leave it, it increments that value. Now, the decrement works the same way. And the only difference that you're taking away 1. So if we know that X is 3, on this line, it will still output 3, but at this time, it'll print 2. For Y, minus minus, here is going to print out 3, and then on the next line, it'll print out 3. So if we run this, we're going to X3 and this 3, but then what? X2, because what? After we left the line, it decremented, and it printed the 2, and then it printed the same value for Y, because Y was decremented at that time. All right? So the plus plus or the minus minus, either one, they work the same. All right? And when I say the same, is either add 1 or take away 1, but the rule for when you actually do it is the same. All right? So if you see that in code, don't get confused. Just know that you either add 1 or take away 1, but you got to know if it's pre or post and when it actually is happening. Okay? All right. Counting backwards. We looked at that. Remember we talked about a person could count forward 5 or backwards 5. And the same thing here. So what? you don't always have to count up. You can count down, right? Either way it go, but you would have to have your test conditions set properly in order for you to what? Do it. Because otherwise you could be in a what? Infinite loop. Because if I'm at 0 and my test is while x is less than 5, and I'm decrementing my counter control, I'm going backwards, which I'm going to be in an infinite loop because I'm going to infinity toward the negative side. So you got to be careful when you're writing your programs. All right. All right. And like I say, the counter, we went through this too. Letting letting the user control the number of iterations. All that means is what? You could even have it to where a person enter a value. Please enter the number of times you would like to perform this loop. Watch, where we can go back to here. All right. So we had, let me go back. Let me do Z. So I'll go back here. Hopefully it have enough in my memory to remember all of it. Because sometimes you have a limit. All right. All right. So we have this for loop, all right? So say we have this loop here. That should be, oh, well, I'll just take this out. Yeah, take this out. So we have this loop. Oh, well, we still got the other loop. All right. So now, say we have our for loop. Everything's so much jammed. All right. So we have this for loop. Rather than do a const, I'll just say int times. All right. Now, all right. So what I can do here, I could say cout or enter the all right, times table you want to print. All right. Now, semicolon, and then I'll do cn times. Right. Now, what happens here is now I could go to count, but now well, that's the times. But then too, let's see. I could say enter, no. All right, so the limit you want to read. So if we want to go to 5, we'll put 5. We want to go to 2, we'll go 2. All right, so then cn, and I'll say limit. So now what happens here is, and I have to declare limit. So now what I can do is, right here is for count is equal to 0. That's my starting point. Count less than what? This would be limit, all right? If I want to do up till 6, that would be it, limit. And then everything else will be the same. So now when I run this, watch, it's going to act, hopefully I got my semicolon, I bet. Yep. All right, so when I run this, it's going to ask me for the timetables I want to do. All right, what timetables that I want to print? So I'll do 7, the 7s. Okay, what limit? Okay, from 0 to whatever. I want to do up until, say, 5. So it's going to do 0 times 7, 1 times 7, 2 times 7, 3 times 7, 4 times 7, and 5 times 7, and stop. So when I hit enter, See, it went to 5. Because what? My limit, I'm saying count from 0 to limit. So I actually typed in a value to where I wanted to control, when my control loop to stop. Okay? If I run it again. So see how in computer science, man, it's many different things you can do, many different scenarios, etc. I'll do 4. I want to do the 4 timetables, and I want to go all the way to 8. All right? See here? Went all the way to 8. All right? So, and there's the 4 timetables. So, like I said, using variables, etc., man, you can write code to do anything you want. Anything you can imagine, you can write code for. All right? So don't try to just think in the box. Think outside the box. When you're at home, try writing code to do some things. And then if you have issues, you got to question me, question the internet or whatever. I was trying to do X, Y, Z. How would it be able to be done? If we don't know, we can look it up or like I say, we can find and research it. But try to have your mind working on thinking on solving problems, because that's computer science. That's what computer science is. All right? So that was that section. All right? And look, designing a counter to control a while loop, same thing. Just like with the for loop, I told you those three sections: the initialization, the actual test, and then the increment. So if we had a while loop here, this would be while count is equal to this. Well, no, we'll do that. This would be the initialization. Then this would be while count is less than or equal to limit. So we inputted limit. So limit would determine how many times the while loop would perform. And then we would have count plus in here. All right? Because as count increments, it's getting to limit. Okay? And as it get to limit less than, when it get to greater than limit, it kicking out. All right? What else it says? If you forget to increment the counter variable in a count control while loop, you're going to be in an infinite loop. Remember, we talked about that. If you don't increment that counter, you're forever stuck in an infinite loop. And I'm going to tell you, sometimes that's some of the hardest things to figure out and to find when you have those type infinite loops and you're wondering what's going on. I got my if statement, and then when you have and or, and it's like you got to know what's true, what's false, and whatever. So that's why you got to understand math very well. You got to know greater than, equal to, not equal to, and all this stuff. You asking the questions. You asking them to get the true or false, so that the program can follow what you're designing it to do. See, that many people in computer science figure that the computer will direct them as to how to write the code. The computer does not know what your logical problem is. You know what your problem is, so you are writing the code to fit whatever circumstance that you're writing it for. The computer just gonna execute what you give it. So you got to be able to know what it is you're working with, or what the problem is. And a lot of times we tell students, know the problem. Make sure you know what it is you have to do. Don't just go off and say, oh, I'm gonna write this code. You will get stuck. And like I say, as you grow into the different classes and build on writing code, it's gonna become more and more important to be able to track what you're doing and keeping up with what's going on in the various places and subroutines and whatever. So like I say, just make sure you kind of get in the habit of working with it. Because the more you use it, the better it's going to be for you. All right? We talked about this, initializing the values and whatnot. About counting backwards, we talked about that. Because what? Class is it's over. Let's do this. Because I could go backwards. I could start 10 and then greater than 0. We could do that. You can do this in the program, but then we have to do whatever minus to get to whatever. All right? So that can be done. So you always can reverse logic in a program too. All right? calculating a running total. Okay, we'll look at this and then we'll call it a day. And like I say, we got the Sentinel. I think Sentinel is it. Nope. Nested loops. That's some stuff. We'll look at nested loops on Tuesday. And Sentinel values and nested loops on Tuesday. Calculating a running total. This sometimes gets confusing with students. All right. Look at this program. This program, we are calculating val, right? But every time we run through this program, val is being overwritten. All right. Let me make this a little bigger where you might can see. All right. Val is being overwritten in that the first time through count is 0. All right. And we're going through this and it says count time times. So times is whatever number we put, say 4. So 0 times 4 is going to overwrite what val is. And say that's 0. Second time through, count becomes 1. 1 times 4 is 4, so it's going to overwrite val. If we wanted to get an accumulated value, all right, we want to calculate a running total. Say we wanted a running total of the values, and let me bring this up here. Give an example. Say we wanted to get a running total of the values, these values, 32, 28, 24, 20, 16, 12, 8, 4, and 0. Whatever those numbers are, what is equaling to, which is val, we want a running total of that number. What will we have to do that is we would need a variable, all right? So I'll just make a variable called total. Now, and I'd have to set it to 0 if I'm in online GDB because I cannot use it other than that. What happens is now I have to do something like this. Total is equal to total plus val. So what happens here is every time val changes, it's like the first time through, 0 is equal to 0 plus 0. So it's going to be 0. So if val is 4, 0 is equal to 0 plus 4. It's going to overwrite that with 4. Next time through, 4 is equal to 8. A 4 plus 8. And it's going to take 4 and 8, make 12, and it's going to store that in 12. So now you're getting a running total. The reason being, this variable is on both sides of the equal sign, all right? So that way you're not what? Overwriting a value each time you run through. So now what I can do is, outside of that loop, then I can do a cout something like this, and then write out the total. All right, so now let's run it. And like I say, depending on what we put in, I'll put in a, what happened? Invalid output here. I'll put in a small number where we can check it and see what it is. All right, so we run it. All right, enter the number. Say that we do the 3's timetables, okay? Say we do the limit 2. All right, look. 0 plus 3 plus 6 is 9. See? So we got that running total. All right. And even if we do a larger one, we'll do the tens timetable. All right. And we'll do up to 5. All right. So we got what? 50 times 40 times 30. That's what? That's 90. 120. 140, 150. So see, I got the running total of these numbers. All right. So that it didn't overwrite the number and just give me 50. It actually accumulated my number. All right. So class, we'll call it a day here. Anybody have any questions? Any questions? Questions. But that's how you get a running total. Your variable has to be on both sides of the equal sign. See here, set total equal total plus number. That means every time it adds number to total, it increment in total. It's not just saying overwrite with a new value. Well, it is a new value, but it's going to be the value that total is plus the value that number is. All right. So that's how you calculate the running total. So if there's no questions, like I say, on Tuesday, we'll complete this chapter, and then I'll assign the test on Tuesday, and like I say, we'll go from there. But the programs, let me see, I didn't even log in. What I'll do, I'll open up the assignments. Let me go to Canvas. I'll open up the assignments for y'all to start working on. Are they already? They might be already open. No, they're not. All right, modules. Chapter 5. All right, and remember, I have 3 programs. They all perform are created to use loops. One, a for loop. The next one, exact same situation, a while loop. The next one, exact same situation, do while loop. All right. So these 3 programs are identical in that they have the same requirements, other than you using the different loops. All right. So I'm gonna post those, and like I say, work on those. And like I said, we'll answer questions on Tuesday also, and I'll make them due Tuesday night. But don't wait on them. Make sure you work on them so that you can come to class with a question. All right? Because like I said, if you just wait till we have class, somebody might not ask a question that you need answered, or either you might not be able to answer the question that you need to ask because you didn't go over the material. All right, so make sure you go over those programs. Try to work them out before you come to class. So if you get them right, cool, you got it. But if you run into issues, at least we can talk about them. We can try to go through it so that we can get you to understand what's going on. All right. So I'm posting these right now, and you should be able to turn them in at any time. All right. So if that's it, no questions. If there's no questions, I'll see y'all on Tuesday. All right. All right. Have a good one. What's the last one?
Sterling said she forgot to sign the roll.
Oh, okay. Oh, yeah. I don't be looking at the chat. I'll just be talking. A lot of times I ain't even looking at the camera. I just looking dead at the screen and talking. And sometimes I forget I'm just here by myself talking. But y'all gotta communicate back and forth with me. Let me know. Okay, I get that. Or let me know. Oh well, go back. I didn't really quite get that. All right. All right. Let me add them to the roll. So I'll see y'all next class period. All right. Who else didn't sign the roll? Anybody else? I might need to go to.
It's just us now.
Okay, all right. So I'll add this
stuff. Professor.
All right, have a good one. All right. Okay.